donc cet entretien se fera en anglais. J'ai une application QR code qui s'appelle de ce qu'on va dire en anglais directement dans votre application. To be here. On the left, we have who is from Stanford, founder of Seal Tracking, which is your company. Space improve the state. Thank you. The space debris removal.
Yes, thank
you. Bonal from NES launches direction in to the Space Debris Federation and the start with debris, exactly.
Situation which is slightly wrong since 1950, but also the first debris, because the also, and so these were the first just grew of debris, of objects above our heads, 8,000 tons. Typically, objects of the size of the fist, centimeters, 24. If you go a little bit, 1 centimeter, kinetic energy, millimeter. Kilometers per hour. If you hit the computer of a satellite, talk.
Where are those debris?
.100, 1,400 kilometers. Then we skip to 20,000 kilometers, where we have navigation satellite, GPS, GLONASS, Beidou Compass, Galileo, of course. I was not going to miss it. And then another step, we go to geostationary Earth orbit, where we have today 521 active satellites plus 1,100 debris. Large satellite dead, which have been left there. Okay, so 2/3 of the population in geo are debris.
And what is the nature of these debris?
Mostly,
what are they?
We have 50-50 between the large objects, entire objects, mainly dead satellites. Typically, we have 4,000 dead satellites. Okay, a satellite has a useful life of, let's say, 10 years. And after this, you leave it there, except if you do as my friend Guglielmo, who takes it down. But otherwise, you leave it there, and it remains there for ages. Then you have all the upper stages which have been used to launch rockets, which have been used to launch the satellites in orbit and have been left there. Then you have plenty of objects that were used during the mission, you know, a shroud, which have been separated, or when you launch a telescope. On the telescope, you have a cover to pass all the atmosphere phase, and once you arrive in orbit, well, you just jettison the cover, and it's still there in orbit. So that's half of the population. The other half of the population are fragments. Fragments coming from explosions, fragmentations, and collision. When you have a collision, you regenerate a large number of debris. So each time you have a collision, it generates thousands of new debris of any sizes.
Thank you.
Thank you.
Guglielmo, why are they so dangerous, those debris?
Well, as Christophe was saying, basically they travel at such a high speed that if one of these debris hit a new satellite, it could easily destroy it. And we know how we rely on satellite technologies today. For example, we use the GPS every time, or people watch, satellite television, weather forecasting. We rely so much on these technologies, and every time we put in orbit new satellites, so the last thing that we want is that any of these new satellites is hit by one of these pieces of debris.
Amber, so you work to solve the problem. How did you hear about space debris for the first time?
Yeah, so space debris has actually been popularized a lot by a lot of popular culture. So as you may recall, the movie Gravity really talks about like the impact of a large amount of space debris. But also a big part of the introduction to the problem for me was when I watched one of the blogs published by astronaut Scott Kelly when he spent his year abroad in space. And at one point in time, he talked about how he would have to duck into the Soyuz capsule to avoid being hit by debris. So this was like a big introduction about how problematic this issue actually is.
And why do you want to solve this problem in particular?
Yeah, so I think that there are three main aspects to why this problem needs to be solved, specifically by a private company. So number one is that this is a big environmental issue, and that a lot of the space debris that is of particular concern is in low Earth orbit, which is where a lot of operational satellites are operating out of, and that is really problematic for a lot of human functions that rely on these satellites. Second is that when we want to launch things into space in the future, currently people need to find an optimal time to launch their payloads or their rockets to avoid being hit by debris. And if the space environment continues to be more polluted, then this will be increasingly problematic for future generations to launch.
So future is very a thing you think about.
Yeah, I think in order to continue space exploration, we need to make sure that the environment is not as polluted as it is.
Is there really a risk that space exploration would be stopped because of space debris?
I think right now it's not a huge risk, but I think if people keep with this attitude that, oh, it's not a huge risk, and they're not keeping this in mind, then it could be problematic.
Christophe, are there laws to avoid debris in space right now?
Laws, there have been plenty of regulation at international level. We started in '95 with the American standard, then followed by the Japanese in '97, then CNES was third in '98. Then we turned an international level with the IADC, Interagency Debris Coordination Committee, where we arrived with a text, the guidelines of the IADC in 2002. In 2002, they were approved by all the countries, including Japan, India, Ukraine, Russia, and so on and so on. These texts were then translated into more formal text at UN level in 2007, then at ISO level, International Standardization Organization, 2010. And so every country has its own standard or guidelines or rule of conduct With one exception, France is the only one to have a real law. We have a law on the French Space Operations Act, which means as soon as you do an operation which is under responsibility of France, for instance, launching from the Kourou, from the Guyana Space Center, then you shall follow the law. And it's a strict law. If you don't follow it, you have problems, okay? All the other texts are best wishes. It would be good if you could do this, okay? And so today, to answer your question, yes and no. We have some laws, we have some texts which are more or less strong. We have plenty of goodwill, good wishes, saying, please do this if you can, and nobody does it. The main problem that we have today is that these texts are very poorly complied to. If you take satellites of 100 kilogram, for instance, above 600 kilometer, which is the most critical zone, the rules, the international guidelines, which have been adopted already 20 years ago, are complied to only in 18% of the cases, which means less than one satellite out of 5 follows the regulations that we have. And this is really problematic.
Guglielmo, about
well,
this?
if I can add something, the problem is that these are all guidelines, but unfortunately there is nobody that can really enforce them. And so this is one of the issues that we all, the scientists and so on, we all agree that it makes a lot of sense to follow these guidelines, but then every now and then someone doesn't follow the guidelines. For example, when there have been experiments to shut down a satellite using a rocket launched from the ground and produces a lot of debris and so on, we all agree that maybe it was not the best thing to do. But fair enough, sometimes some countries want to, follow a particular way, to demonstrate their capabilities. And unfortunately, there isn't much that can be done to really prevent this. One can try to apply, let's say, political pressure, but there isn't really anyone that can actually really enforce these kind of guidelines. And so this is one of the issues.
Amber, do you take those laws or these guidelines into account for the work of your company?
So specifically, my company deals with mapping space debris. So it doesn't really need to follow any specific regulation.
So you know how to locate space debris. You map them. How do you manage to map them, actually?
Yeah. So basically, the software that I'm working on takes data that is actually collected by radar. So radar specifically is collected by the government, operates a few, and specifically a company called Leo Labs actually has about 7 radars located across the world, and they take daily mappings of debris. So I take the current positions of space debris, and then I have an artificial intelligence software that is basically able to propagate future positions of where this debris will be. So I'm able to do this about a week in advance. And the ideal goal is to sell this data to companies, specifically satellite companies or any company with payloads, to show them where debris might be in the future. And they can do this for collision avoidance, threat avoidance purposes, basically being able to map all of the debris and then show potential collisions with orbits is the goal here.
Wow. Congratulations.
Thank you.
It seems amazing. Guglielmo, you are the PI of a space mission called Remove Debris. So what is this mission and how did it go?
Well, that has been, let's say, like the first mission to give a real demonstration in space of technologies to actually go remove these debris and then deorbit them. And what you can see in the video is actually the animation of this demonstration. So the satellite that you see has been released by the International Space Station. To give you an idea, the size of this satellite was about, a washing machine, let's say, about 100 kilos. And so we have released a first CubeSat that was like pretending to be one of these space debris. It inflates a structure, as you can see now, to become a bit bigger and be more representative of the size of some of these debris. Then a net has been launched to actually capture the debris. And later you will see the video actually of the real experiment in space, because this is just the animation that we did before the mission to explain what the mission was about. The second experiment that you see now is about a camera to observe a debris, and from the observation figure out exactly the distance, spinning rate, what this debris was doing in order to plan the capture. The third demonstration was another way to capture a space debris, which is basically firing a harpoon that is connected with a net to the mothercraft, so you can capture your debris and then you can deorbit your debris, actually pulling down, let's say, to Earth. And the final experiment that you see there, the fourth demonstration, was this drag sail is called. So it's an inflatable structure first, and then there are four tubes coming out that open up a sail, and this sail reduces the speed of the satellite, so the orbit slightly reduces its altitude until the satellite burns into the higher atmosphere. So this would be the last phase when you want to dispose of your satellite after the useful life of the satellite, and so you can burn it into the high atmosphere, and so it doesn't contribute to the debris population.
I think we had real images from this mission.
Yes,
Maybe if we could.
There are a
if we
couple
could
of
have them.
nice videos that actually show the experiments in space. This is the net demonstration. Okay, what you will see in a minute. Yes, these are real images taken by the mothercraft that CubeSat has just been released. You see different quality of pictures because we had different cameras on board the mothercraft. For example, these type of pictures are with a LiDAR camera that allows you to figure out exactly the distance of the object. Then you see the inflation and the net being launched to capture the debris. You see the net had 6 weights at the corners to try to envelope the piece of debris. You see different views because we had different cameras that we used to video the experiment. The target was spinning around, like happens sometimes for debris. That plate that you see, that white disc, was actually the cover for the net compartment that is also tied up with a string to the net. And the next experiment, you see, is the harpoon demonstration. So that target that you see is actually representative of a real structure of one of the old satellites. For example, Envisat was the one that we considered. And as you see, firing, you see the cable, the wire that is connecting the harpoon. And so these were two, successful demonstrations that have shown that, these kind of technologies, which are relatively low cost, if you want. Everything is in relative terms because space technologies are always end up relatively expensive. But these would be relatively simple ways to actually capture these debris. And once you have captured them, you have to try to deorbit them. So the mission is basically finished. We have activated the last of the experiment, the 4th payload, about a couple of months ago. So now the satellite is coming down.
And you said that it was a low-cost mission. Can you say how much it cost, or you can't say?
Yes, again, low cost is always in relative terms. The cost of this mission was about 15 million euros, and half of it was actually sponsored by the European Commission. So we have to be very grateful for the sponsorship. The other half was actually put by the partners, because this mission was carried out by 10 partners, so led by the Surrey Space Center, but then there was Airbus, France, Germany, UK, Surrey Satellite Technologies, various SMEs in Europe. So it was a consortium of 10 partners that came together in order to put together the mission.
And are you happy with the conclusions of the missions?
Well, we were sort of delighted because, as you can imagine, it was quite a complex mission. And I have to say that this mission has attracted a lot of media attention, which was good because at the end of the day, we want to attract the attention of, politicians, all the relevant authorities, in order to help us to address this problem, because I think one of the big issues is who is going to pay them to do these missions and clean up, space. So the more we can raise the profile of this kind of issue and attract also, let the public opinion know that, there is this issue, the better it is.
Christophe and Amber, did you follow the mission when it was in space?
On a daily basis. We were in contact. No, you should realize that it's really a first, absolutely, and it's a must to demonstrate these kind of technologies. And they did it remarkably well, small size, but representative. And so it's really, the process, you start by writing PowerPoints, and then you say, oh, it would be fun if I could test it. Then you test it in a lab, but with 1G, gravity, with air, and not the same. So then you say, oh, it would be good if I could test it in 0G. Then you
Zero-G
go
flight.
in the plane, 0G, and then you say, yeah, but it would be better if it could be in vacuum, and so on and so on. And so what they did was absolutely the ultimate step before the full-scale one. And so what they demonstrated was fundamental for all the future active debris removal missions. The techniques that have been developed here, such as a net or a harpoon, are fundamental because, as Guglielmo said, usually the debris, we say the debris are non-cooperative, they don't help you.
No.
They are non-prepared, you don't have a handle to catch them, and they are tumbling. Not always fast, but 3, 4, 5 degrees per second. And that's quite tricky because if you want to catch something which is turning. So the best ways is to catch it with a net, and you saw that his debris was tumbling quite fast, indeed.
Yeah.
Okay, and so it demonstrated that it could do so. And with a harpoon, that's the same thing. You must imagine that it was really representative because if you harpoon a huge satellite, you will aim at a zone which is exactly 20 centimeter by 20 centimeter. You know exactly where you want to harpoon it from 2-meter distance, and so you just wait till the target passes in front, clack, and then it's done. So they really demonstrated plenty of things, and now I'm keen to see the detailed results and with the what went well, what went wrong. Hopefully, I hope that some things went wrong because otherwise we don't learn anything.
Yeah. No, again, very kind words, but as Christophe said, the in-orbit demonstration is essential because when we do the test in space, we always represent some parts of the environment, but not the whole thing. So for us to give this in-orbit demonstration was essential to give confidence that actually now we can go for the next step, which is really to capture one of the large space debris that is actually orbiting around Earth. For example, there is a potential candidate was this satellite, Visat, but there are other candidates, and the mission has shown that really it can be done. There are other candidate, technologies like a robotic arm and so on, but what we wanted to try to focus were things that, in our opinion, are relatively simple and versatile, because again, as Christophe was saying, if a debris is spinning, to go and grab it with a robotic arm is not as simple as it might seem, and capture it with a net or with a harpoon seems, let's say, a simpler option.
Amber, you seem to agree?
Yeah, no, I think that what was done with the removed debris mission was extremely novel. A lot of different private companies have been trying to tackle this problem for a long time. So it was great to see the tremendous results that came out of it.
Christophe, you once said to me that debris removal is useless today as long as we put more and more debris in space. So what can be done by space agencies as long as space traffic is concerned?
Yes, as I said previously, it's today we have a problem because we don't respect at all our rules, and so we're just polluting space. We're sending new things that we leave in space. We're once again we are not compliant at all to our rules. For instance, let me take an example. In 2018, we left 588 new objects in orbit and removed only 300. So the delta, 288, wow. Okay, so as long as we generate debris like this, active debris removal is useless because you will not, you cannot compensate the bad behavior, okay? But on one hand, we're trying to improve the situation, we're explaining to everyone, please don't do this, think of our children, think of future exploration and things like this. So we hope that we will be able to lower this figure drastically. Once this is lowered, probably this will not be enough, because probably even if we are very clean, the number of objects will continue to increase due to what is called the Kessler syndrome. Kessler syndrome is the film Gravity, if you remember, okay? And so to avoid this, then we will need definitely active debris removal. And okay,
could you explain could you explain more what is Kessler syndrome?
Kessler syndrome is in orbit you generate debris and you have a natural cleansing due to the atmosphere. The atmosphere helps you to clean the orbits. But when you generate more debris than you clean them, then of course the number of debris will increase. And then the mutual collision between debris regenerates plenty of objects. You've seen the film here, for instance. These were two satellites, so Iridium 33 and Cosmos 2251, which were not even very big satellites. They were in the frame of 800 kilograms, 750 kilograms. They collided in February 2009, and they generated 4,000 catalogued objects, meaning 4,000 objects larger than 10 centimeters. Any of these 4,000 large objects hitting a new satellite will kill it and will explode it again. So you can have a cascading effect, and then you have an exponential increase in the number of objects. And so the Kessler syndrome is, the clear definition is, even if we stopped space completely tomorrow, no more launch, no more activities, okay, it's not very good, but even if we stop completely, the number of objects in space will continue to increase. And so the only way to stop it is, first, be clean.
Yeah.
Second, go and remove. Okay.
Guglielmo, about this Kessler syndrome?
Yeah, and I think, well, Kessler was a NASA scientist that was actually the first that really started to work on this problem, and what was the density of debris that then would trigger this sort of issues.
76.
Yeah, exactly. But I have to say that lately I haven't seen a lot of activities, you know, whilst in Europe, ESA, for example, is doing a lot and so on, in the US, besides the tracking, that there is a lot of effort, actually, they are doing all the tracking, they hold the catalog of all the objects and so on, but they do not seem, you know, really particularly active in the area of the debris removal.
Yes and no, because one of the main problems with space debris removal is who's going to pay? Well, who is going to pay 10 million euro to go and remove a piece of junk which has absolutely no value, potentially dangerous, and so on and so on? Oh, please don't touch it. And so this was the major hurdle for the active debris removal. And this is the reason why it did not start yet. And among the key solutions today, there's one very nice solution, which is called the space tug, the on-orbit servicing. We are developing vehicles, orbital vehicle, which can do any kind of mission to satellites. So on Monday, they go and refill a satellite. On Tuesday, they go and inspect another satellite. On Wednesday, they repair. On Thursdays, they move from one place to another. And on Friday, they deorbit with the debris. And so we really believe that the key for active debris removal now is can be found with the on-orbit servicing, the space tugs. And so these space tugs, today Airbus and TAS are developing their own. In US, there's the first space tug will fly this year, in 2019. I think it's the removal mission, which goes, Restore L mission, which goes and refill Landsat satellite. And so it is arriving, it is now. And this is a way to pay for these activities, you see?
Amber, you said that private companies aim for mapping and projecting debris. Are they concerned about putting less debris in space?
Yeah, so I think in the past few years, a lot of companies were really not too concerned about launching things, especially since the cost of launching like a CubeSat is becoming increasingly cheaper. But recently, the United Nations made it mandatory for certain companies to have a metric about how safe they are and about their payloads and about whether or not they will cause space debris. So I think because of that, a lot of companies are becoming a lot more wary about the problem. But going back to the issue of tracking, I think a lot of companies are still concerned about whether or not their space payloads will collide with orbits, space debris orbits. So the problem with tracking space debris is that space debris actually follows a very non-Newtonian method of orbit because it's impacted by so many external factors like drag, Earth gravity gradient, solar radiation, all of these things that aren't really accurately modeled in Newtonian mechanics. So a lot of current methods for tracking and predicting space debris orbits use an integration method that really relies on this Newtonian mechanics method. And because of that, there are very, very large error metrics when it comes to predicting where space debris goes. So that's specifically why I'm trying to tackle this problem using artificial intelligence. So rather than having a set model or following a set Newtonian mechanics method, I'm rather learning about the patterns about how space debris positions and orbits are changing through various epochs of time to produce future error metrics. But a lot of companies do have their own integrative methods for predicting space debris, and because of that, I do think that a lot of companies are very concerned about the problem, and especially with the new metric that the United Nations is introducing, which makes it mandatory for certain companies to release how safe they are. I think that a lot of people are going to start putting in a lot more attention to the space debris effort.
Christophe?
I think the jobs that Amber just described is absolutely fundamental for tomorrow. It's important. So we're talking about avoiding collisions, okay? And avoiding collisions, so that's a daily job for plenty of teams around the world. And one of the main problems is, as Amber said, we don't really know where they are. A typical thing, let's just to pop up some figure, you know where a debris is, plus or minus 1 kilometer, plus or minus 100 meters laterally. So it's a kind of ellipsoid, kilometers long, with just one object, maybe 10 centimeters in the middle, or not even in the middle. Okay, so it leads to a very high complexity in predicting the collisions. For instance, my colleagues in Toulouse, we have a team called C2O, Centre Opérationnel d'Orbitographie, where they work 7 days, 24 hours, just to protect our satellites. In 2018, they had 3 million alerts. 3 million. I think that it's one every 10 seconds. Okay, so the main problem...
That's a lot.
That's a lot, and that's today. As I said previously, tomorrow we'll have all the CubeSats, tomorrow we'll have all the mega constellations, and so on. So tomorrow's situation will be much worse. So we definitely need, out of these 3 million conjunction, 99.99% were false alarms. But you need to work them out to understand that they are false alarms. So this is why jobs that you're doing is absolutely a key for future, for tomorrow. Otherwise, we'll be drowned under false alarms, and we don't know how to work it out.
Maybe that's a naive question, but do you work with insurance?
Yeah, so that's a very interesting area. Specifically, I am trying to work with insurance companies because that actually is a lot of, like, a huge concern. And especially since space premiums for insurance are extremely expensive. So just trying to have that a bit more accuracy in knowing whether or not a mission will be successful will be hugely important.
But you should realize that today, in low Earth orbit, there are only 5% satellites which are insured.
Yeah.
All the rest is
That's why I thought it was a naive
yeah.
question, but it's not actually. Guglielmo?
Well, yes, thinking about the insurance, clearly we were one of the 5% that had to be insured because the UK is very keen that we all follow the appropriate rules and so on. So you can imagine the discussion with the insurance company about the satellite that had a harpoon, a net, which are not really the kind of thing that are normally flown. So it was a very interesting part of our project. But yes, it is, the issue of the insurance is very important because, again, these collisions can happen, and so it is appropriate that the satellites are covered.
Guglielmo, do you know any other missions of debris removal?
Yeah, actually, what was mentioned before, ED orbit, actually everything started like with that. The European Space Agency has been, I would say, leading the way in this area, looking about, the world. And in 2012, I think one of the large European satellites stopped working, and so they decided to possibly, investigate the possibility of a mission, which was called, again, ED Orbit, 2013 we are talking about, to go and recapture EMISAT. And I think there were 2 consortia that actually investigated the problem for quite some time. And at the end, it came out that was still a bit too challenging. And therefore, the project, I would say, has evolved into where we are now. And this vehicle that can do servicing, can do active debris removal, the one you were mentioning before, basically, which seemed a very good idea, because if you have, again, a multi-purpose vehicle that can actually go and remove the satellite, but that can be like the last thing before it could do a lot of other useful things, then you are much more likely to have industry involved in these things. And so, again, from the initial mission that was about let's go and recapture one of these large space debris, now the European Space Agency is sponsoring this wider, let's say, purpose mission that is indeed very useful. Around the world, I think in Japan, they seem to be very active. There is a company called Astroscale that is putting together various types of demonstrations, so indeed important. Even, I think Switzerland was doing something, because a few years ago they put in orbit a CubeSat, so now they wanted to do a mission to actually go and recapture the CubeSat that they put in orbit, a few years before. The latest news that I've heard about, for example, Russia, is that they were investigating, like a space lasso to go and capture some debris. And if you believe what was Fox News, they are developing big space lasers to go and blast all the possible satellites. But there is a lot of activities going on in this sort of area.
Yeah, Europe has been very proactive, and as Guglielmo said, mainly thanks to the team in ESA called Clean Space from Luisa Innocenti. They have been working on every single techniques. Some failed, some succeeded, they pushed, and really they have a complete panel of activities which is unique in the world today. And they have been working with all the companies in Europe, in complete Europe, and so everyone is very motivated by this. And this has given things such as your project and things like that. So we have the Swiss from EPFL, Muriel Richard, and so we have several examples.
Yeah, we have to say that Europe in this area seems to be really at the forefront.
Mm-hmm. Great. Do you work with these missions or these projects? Are you, I don't know, giving datas or maybe to map these projects of missions?
So currently not yet, but this summer we are planning on launching with a few satellite companies and trying to predict collisions with their satellites. We have yet to move on to actual bigger missions, but mostly focusing on private companies right now.
Okay, so what do you think about those mega constellations of CubeSats? What do you think about the future? What is your opinion on that?
Yeah, I think we need much more of this space traffic management. Because again, like it happens here on Earth, when things start to be a bit busy, we need to have some sort of regulations. But I think that the issue on which we touched before, we need to try to make sure that everybody actually follows the regulation. This, I think, is one of the crucial issues.
What we have seen clearly with all these mega constellations is that if they follow strictly the rules that we have given, then no problem at all. And so
yeah,
clearly,
but space is hard, so
it means just that if they comply to the rules, then it's fine. And the good thing with them is some of them, I will not quote who, but some of them, since the very first day, they came to see us to have all the explanations about, please, tell us about space debris. Why is it so? How can we do so? And their immediate answer was, okay, we'll be better. We understand that it can be a problem, that we can be a problem, so we'll be better than all the other ones. And really, on the paper, or when you listen to them today, they should be 10 times better than anyone else. Now, okay, well, let's wait and see. But so far, so good. So far, so good. They've said that they would comply to everything, even better than all our rules. And if they do so, then there is no problem. It will just be a perfect satellite, and they will go down, and there is no impact. And this has been simulated at length by all the delegations in IEDC, and there should be no problem. Now, shit happens, and so if something goes wrong, then it can go wrong very quickly. Because, for instance, these constellations, one of them is at 1,200 kilometer. 1,200 kilometer, it means that you're stable for 2,000 years. So it means that if you explode up there, then the debris will remain in the operational constellation for 2,000 years.
Whoa.
And
Yeah.
not good.
No.
Yeah, I think that the point is that now there is much more awareness, and so people try to design in their mission than the final way to dispose of their satellite and so on. Whereas in the past, we were a bit more relaxed. People were putting in orbit things, and then we said, well, we'll think about that tomorrow. Instead, if you engage with the issue, as you develop your satellite, as you develop your mission, it's much easier, and you can maintain again the sustainability of the space environment.
Look, for instance, the OneWeb constellation, which was developed by Airbus. They say, okay, we are very, very reliable to deorbit with 99% or 99.9%. So we will deorbit, no problem. But in case we don't, they added a handle on the satellite so that we can come and grab it and retrieve it. That's neat. See?
Yeah.
I've got several questions from Twitter. So, first one is for Amber. Amber, what is the minimum size of debris you track? What percentage does it represent on total amount of space debris, and are you able to know details?
Yeah, so actually the algorithm that I'm using is actually not exclusive to any specific size. So basically whatever the radar is capable of taking in, I'm capable of tracking. Unfortunately, it's really hard to know the exact size of the debris. The only metric that I'm able to use is typically we use the two-line element set, and then the drag coefficient in the two-line element set is directly related to how big the debris is. So if it's a larger drag, that means the object is larger. If it's smaller, then it's a smaller drag coefficient. So not exactly able to know the exact millimeter size, but the algorithm is basically able to track a very wide range of sizes.
Oh, thanks. Guglielmo, the second one is for you. Is removed debris reusable or not?
No, well, exactly. The idea is that it's a bit like a kamikaze mission. You go, you capture one of these pieces of debris, and then the satellite, the mothership, deorbit with a piece of debris that has been captured. In theory, it would be possible and has been investigated to go and capture, for example, various debris, but the problem is that these debris are often in different orbits. So to go from one to the next is going to be a bit challenging, and you might need so much fuel that maybe it would be better to have two separate missions. But so, we tended to focus really on this, just go and capture one and deorbit one, but the technology in theory is versatile, and also some of the things that we have investigated, for example, the visual-based navigation, these cameras and so on, those are good for any type of mission, either to go and capture one single debris or to go and capture, various debris.
Okay, thank you. The other one is for you, Christophe. Space debris materials could be toxic. Deorbiting debris and burn them in the upper atmosphere could be dangerous for people on Earth?
No, definitely not. It's not. It's never. No, it's tiny. Okay, most of the debris, most of the space objects are made of aluminum and carbon, which are completely harmless. And then realize we are talking about re-entering. Maybe 1,000 tons would be already a huge value. Keep in mind that if you have a super tanker or a container ship sinking, then you are talking about 200,000 tons. So it's completely different figures. We are talking about a tiny amount of objects and purely aluminum and carbon. There is no toxicity at all.
Okay, thank you. I have another question. Maybe we can have question from the public if you have one. When it comes to space debris, often people ask me why we can't see them when we see pictures of satellites of Earth. What could you do? What can you say about this?
It all depends on their size, of course, and their reflectivity, okay, what we call the albedo, which is a power to reflect the sun. They never emit light, okay? No satellite, no. They don't emit light, so they just reflect the sun. So if you have a satellite or a debris which is located as a mirror just between the sun and you, then you see it very well.
Yeah.
There were examples with all the, what was the name of the constellation, which had large panels, and we could see the iridium
Yeah.
flashes. They were so bright flashes. And so this is one of the problems that we've encountered very recently with the Starlink constellation from Elon Musk,
Yes.
where unfortunately it seems that they are very shiny. And so they need to correct it. Today there is only 60 of them out of 12,000 planned. So
Yeah.
I hope it will be corrected. Otherwise, we'll see in nighttime.
What do you think about this?
I think that it can be corrected, of course, that he will correct it. Secondly, I think that it's really a burden for astronomers. I like astronomy, and I would really think that it's a bad thing to have plenty of visual pollution like this. But now keep in mind that these satellites are a problem when they reflect sun. So it means that it's not in the middle of the night. In the middle of the night, even if the satellites are there, they do not reflect sun. So there are some periods. Then the astronomers are professional. They know exactly where a satellite will pass when. Okay, but now if you have so many of them,
Yeah.
and if you need to cut your observation every 2 minutes, then it's a real burden. It's a significant question, not problem, a significant question that will be solved in the coming days or weeks.
Thank you. Guglielmo, about Starlink, maybe?
Sorry, say it again.
About Starlink, the constellation of Elon Musk?
Sorry.
You don't have
No, I'm-
an opinion about that? Okay. Do you have questions in the public, maybe? Just show me your hand so that I can know. No questions? Up there.
Hi, thanks for taking the question. And I did ask this one on Twitter, but I'll just ask it here as well. It's another one for Christoph. You were talking about in-orbit servicing a short while ago. I was just wondering if you could maybe explain some of the key challenges for that technology and how significant you think it will be and when it will start having an impact.
I'm sorry, I didn't get it. So you're talking about on-orbit servicing
Yeah.
of the vehicles and how challenging it is?
The challenges that will be in the way of that technology that need to be solved for it
Okay.
to have an impact.
It all depends on the kind of missions that you do with your on-orbit servicer. Some of the missions are simple. For instance, go and inspect a satellite to check that, okay, you have a problem on a satellite, you want to know whether the an antenna is stuck or whatever, then this is relatively easy to do. Then to go and repair something, for instance, an antenna is stuck and you come to cut a wire just to release, this is relatively easy. Then to go and refill a satellite, that's much more complex because you really need to have the proper interface and plug it in and refill. But it has been demonstrated on ground several times already. It has been done in flight. For instance, the European ATV, the automated transfer vehicle, was capable of refilling the International Space Station. So these are technologies that we master. Okay, and so this will be demonstrated. Now, there are some technologies such as what we call orbital replacement unit. If you conceive your satellite with elements that can be replaced, exactly as was done on the Hubble Space Telescope, where when they had a problem or they wanted to improve a camera, then they can remove the camera and replace it by a new one. This is complex, but doable. Okay, and so it is challenging, but very frankly, nothing today, no sci-fi. Okay, it is completely doable today. And once again, it will fly this year. The second one will fly in 2020, and the other projects are arriving now. So.
I've got another question from Twitter for Christoph. What are the key challenges for in-orbit servicing, and when will it start having an impact, or how important will it be?
It's a very good question. In-orbit servicing, of course, will live if there's a market. Okay, and so a demand, money, how much do you pay, Okay, I go and refill your satellite in geo, for instance. How much do you pay for this? If you pay peanuts, then there's no activity
have
because I
peanuts.
will not be able to go and do it. If it's worth it and if there's a deal, okay, I can go and refill your satellite. You offer me this amount. I make a good benefit with this. Then the deal is on, and then the activity can increase exponentially. So it's a real key question today. It's a real key technology. We have all the technologies to do it. We're starting doing this, and it could be a very promising, very, very active business. But once again, a business is you pay, and I'm satisfied with what you pay. If it's not the case, there's no business.
Yeah, I think maybe some of the issues with that one, also about the refueling and so on, is that sometimes satellites, all the subsystems in the satellite are designed to have a certain life. So one of the questions is if you go there and refuel a satellite when it's close to, the end of its life, you might extend its life, but there is a question mark on how long, because the last thing an operator would want to do is spend the money to refuel the satellite, and then a few months later something else on the satellite, fails. I don't know, it could be a reaction wheel, it could be something else. So the important thing now is to start to design the satellite in a way to consider the possibility of refueling, all these possibilities. So the satellite is designed in a way to allow, in a simple way, for example, through appropriate interfaces. So it's all, it's difficult now to think about performing one of these servicing missions for a satellite which was not really designed for that, but in future it will be much better if the satellites are actually designed already to consider these possibilities.
Yeah, one of the fundamental problems that we have today is that you extend the life of a satellite until it dies in orbit. So let me explain. You design a satellite for 10 years, okay? After 10 years, you say, okay, my satellite is working perfectly fine. I still have some propellant on board, everything is working fine. So I'm asking for a 1-year extension. You analyze and you say, okay, please go. 1 year after, oh, my satellite is still perfect, everything is fine, I still have propellant. I'm asking for 1 more year extension, and then you die. And then you realize, oh, I should have deorbited it 2 years ago. Okay.
Yeah.
And that's a problem that we have every day. Maybe with an orbit servicing, we won't have this anymore. Because if there is a service to go and fetch you at the end of life, which is affordable, then you can take your satellite all the way until it dies nominally in orbit and say, okay, guys, I'm through now, please come and fetch me. You see? And then you can have a natural extension of your satellite of 1, 2, 3 years. Who knows? And that's very juicy. And then if the service to go and fetch you and deorbit you is affordable, then it's a game changer. And so with your technologies.
Thank you so much to you all. Thank you. That was very interesting.
Thank you, Florence.
It's been a
Thank you so
pleasure.
much. Thank you. In a couple of minutes, I will welcome 4 astronauts and 3 American astronauts. So be there. Thank you.